Solving special cases of systems in 3 variables. So each set has a couple of examples of special cases of these 3 variable systems, and there are different instructions for each set, and then you'll have to choose in the other practice problems. But notice that some you'll want to eliminate and some you'll want to do substitution. And I'm going to do one example of each, number 1 and number 6. So in number 1, something that I noticed was that because we're using elimination, I want opposite coefficients. And to get all of the x's opposite, almost all of the x's are opposite with this negative and positive 4, but I thought it would be easy if that x was 4 as well, and these are all 1 as a coefficient, so it would be easy to multiply all of these by 4. So when I do that, I get negative 4x minus 4y minus 4z equals 20. And now I can take 4x minus y minus z equals negative 3, that last equation, and I can add it to each of the other ones. So let's write it again. Equals negative 3. I wrote the third equation twice. I'm going to take that first one that we found, and a lot of solving these is just finding patterns, right? And then I'm going to add the second one, 6y plus 6z equals negative 24. So we will add these two together. The x's cancel out in both of them because that was the point, right? And we get negative 5y minus 5z equals 17. And we get negative 5y minus 5z equals negative 27. And so I look at this and I say to myself, there is no way that if negative 5y minus 5z, if it's supposed to equal negative 5y minus 5z on both sides, but 17 will never be equal to 27, right? This doesn't work. And so this system has no solutions. That's what that looks like. A series of false statements. So you'll work out the other practice problems by elimination, and you'll be able to find another special case that I'm going to look at here in the second example when we substitute. Something that I saw, yes, by substitution. So what I thought would be easiest is I see that the s is all by itself, but I see that it has 3 variables in it. The third equation has only 2 variables in it. And so if I can get them positive by multiplying by negative 1, which gives me r plus s equals negative 3, all the signs flip, then I can get a variable all by itself. And so let's say r equals negative s minus 3. And so I thought that that would be really easy to substitute. So something else that I saw was that these other ones with 3 variables in it, The second one has coefficients of 1, and the first one has coefficients of 3. So what if all of the coefficients were the same? That means that 3s equals negative 3r minus 3t minus 24. So 3s equals negative 3r minus 3t minus 24. And to make it look more like the one on top, to hopefully cancel some things out, just because it says substitution doesn't mean I'm not going to have to eliminate at some point. I'll substitute here in a second. So 3t, I add that to one side, and plus 3r plus 3t. So 3r plus 3t, no, plus 3s plus 3t equals negative 24, because all of, let's do this in green, all of this is the same as this equation here. And I'm going to add it to see if I can't eliminate something, which it looks like I can eliminate a couple of things. It was negative 6. When I add these two equations together, the r's and the s's cancel out. We see that 6t equals negative 30, and so t equals negative 5. So I can use that to simplify this original middle equation and have it look something like this third equation that I've messed with. I might not even need the r that I isolated. Let's see. So when I substitute t into the second equation, s equals negative r minus negative 5 minus 8, that second equation, I get s equals, let's see, s equals negative r plus 5 minus 8. So I would add r to both sides, add r to both sides, and we get r plus s equals negative 3. And I see that that's exactly what I got in my very first equation. Let's highlight this in pink and this in pink. And I got these from two different equations. I got them from two different equations, which means I can still add them together even though they are identical. So let's add them together. We've got r plus s equals negative 3. And I've got r plus s equals negative 3. And for things to cancel out, I wouldn't add them, I would subtract them. Oh, which means I would add my original equation. So r plus s equals negative 3. Negative r minus s equals positive 3. And since everything equals 0, and 0 always equals 0, this means this system has infinite solutions. So that's what that looks like when you have infinite solutions, that everything kind of comes back and it equals itself no matter what happens. Everything equals that value, and it all just comes back down to 0. So you do the rest of the practice problem solving by substitution. Make sure there's substitution in there even if you use elimination, and then elimination in these parts. But then down in the rest of the practice, you can use whatever method you want.